earlier video that we will be discussing what are the different phenomena and the corresponding ideas which actually took birth while doing these experiments. We will be stating those things over here, not discussing them thoroughly, just stating out what are the different things which will be discussed in this particular chapter. So, without wasting any of your time, let's find out what are those things. Now let's focus our attention to why we are actually studying modern physics, or what was the urge around that period of time why the scientists actually pooled in their resources, their energy, their intellect for few problems. So we should understand what was an outlook or what was a problem regarding physics around those days, and then try to let's say understand theory based on the particular background which we have set for the questions. So let's study about the outlook, or let's say the introduction of modern physics. So you are supposed to answer these questions. What are we going to study? Why are we going to study? And how are we going to do it? For that, you need to go back to the time between 1900s to 1950. What happened during that time is, modern physics, as is written in the slide, major developments in understanding the nature in the last century. So as I told you about the time period, during that 50 years, what happened in the field of physics. Now, when I actually arrived at the 20th century, I was done with motion. Everything regarding motion was done, right? Objects moving around, you apply the force, the object moves around with an acceleration and velocity, so and so. I was done with motion. I was done with fluids, I was done with thermodynamics, I was done with waves and everything. Electricity was also at its peak. I was using electricity, generators and motors were there. So the only left out areas were outside this world. That is, start exploring different planets, galaxies, universes, right? So these were the other possibilities. Let's say the other possibility was dig inside a particular substance, that is, search for atoms, what's inside the atoms, electrons, what's inside the electrons, start being in a cycle, that is, digging in at a smaller scale, going up in a larger scale, or that is, start observing the objects which are very small in nature or they are very big in nature. So that was the only left out area. Now, because of the technological limit which I had during those days, I couldn't go out for astrophysics, so as to put it in nowadays. Look out for the planets which are billions of miles away. So I focus my attention on the atoms, or the smallest unit of matter. I started out with this question. So what we did is, because of technological limit, we focused our attention only to deep inside the matter and how small the things are, because of the technological limit. So what are we supposed to do? I want to find out what is the smallest unit. So what I did is I break the substance into smaller pieces and kept on doing that, and then arrived at the smallest unit and declared that to be atom. Now the curiosity is more, what's inside the atom? Right? Is it simply the hard ball, or is it a block, or what is inside the atom? So then the further experiments were done and ideas were put up. Now, if I want to know about a particular person, let's say if you want to know about a friend of my own, so what I will do is I will disturb that guy somehow, try to get a response out of that guy such that I know what are its characteristics, what is his threshold in pain or in fun or in sadness, right? These attributes. I will poke him, I will slap him, I will crack a joke to see his response. That's what we need to do with any other substance. If I want to know how a substance behaves, I want to disturb it first and then figure out its response, right? So for a simple example, let's say you're walking by a stranger and you ask him, can I slap you? And let's say you do give a slap and he's like smiling. So it means he's, he can support a slap, right? Let's say he's a jolly guy. But if you slap a guy and that guy turns and hits you harder, that means he has a lower threshold. So similarly, I have to work with this notion with the atom as well. So what I do is I throw in substances at atom. Now, please keep in mind that atom is the smallest unit I have. So in order to disturb a very, very, very small particle, the only technique, or let's say the only tool which I have, is to throw in light. And how the light behaves, that will give me the behavior or the characteristic, or the, let's say, the makeup of substances inside an atom. So that's what we did. So hence spectral analysis becomes very important. Spectral analysis is basically you throw in light at a particular substance, the light comes out. The nature of the light which you actually threw in is different from what it came out. So comparing what was the input and what was an output, you can figure out what was inside the substance. So that's what we did. So hence spectrum analysis was an important, let's say, subject to deal with, as far as answering the question of what atom is made up of, or how is it made up of, what are the things inside it. So for answering a particular question, I now have to deal with an additional new subject called spectrum analysis. So each question resulted into a creation of new topics, and as a new topic was created, we need to do some research on those topics as well. So that's what happens. So whenever we will discuss an idea, a new thing will pop up. We'll discuss that, wrap it up, and then move back again to the mainstream. Right? This will happen throughout modern physics. Now, before I start off, let's have a look at a particular video regarding atoms. But before we actually start studying about how the atom behaves, or what is our idea or our version of how atoms behave, we should first look out for the different observation which we have. So over here we have an atom. In this particular case, I have picked up neon over here, and there's other neon atom. So the above graph actually shows, or it's the relation between the potential energy and the distance between the two atoms. How? When I actually bring this two smallest unit of matter close to each other, in case of neon and neon, then how does it behave? So let me take the atom, one neon atom, pretty far away, and release it from there. You see that the potential energy is this red line, which is almost a straight line parallel to the x-axis. It's just below it. So as the potential energy is negative, so it's kind of moving down, or let's say that two objects are getting attracted towards each other. This one is not moving because I have pinned it over here. So this atom is slowly moving towards the pinned atom. Now you see that it's actually decreasing, and then it reaches the minimum value, and the moment I take or I actually take this neon atom to a distance where the potential energy shoots up to become positive, the moment, at that particular moment, it's an equilibrium. The forces are zero, but though it actually has a momentum, it shoots up. So when it actually shoots up, actually the potential energy is positive, hence the repulsive force actually comes into play. So it kind of moves away. It's like hitting a particular wall, like this. It's like away and away. I can keep on playing with this. Now let's pick up another case, argon. Again, in case of argon, you will see this line is very close to, that is, it's still very close to zero. It's almost not moving. If I take this argon atom at a similar distance, as I took for neon case, it's almost not moving. Then it has a steep slope. Again, the same case. Now let's pick up the third case, that is oxygen. How do you think will oxygen and oxygen atom behave? That is, I have one oxygen atom over here, another oxygen atom over here. What do you think will be the behavior? We know that oxygen exists in the form of O2, that is, two oxygen atoms combined together. So my thinking or my analogy will be they will stick to each other. So let's see what actually happens. See, the moment I leave it, it's almost x-axis, so it's not at all moving, as if this is non-existent to this and vice versa. Now I'm slowly moving towards the pinned oxygen atom. Still not considerable or observable amount of movement or any sort of attraction. Now let's bring further closer. Right? Now I can see there is an observable movement. Now see what happens. It's kind of locked over here. That is, the potential energy is so high, the force of attraction, that is, it's sucked into towards the other pinned atom. But as it moves inside, you'll see now this is the repulsive force. Now it will be thrown outwards. So when it is thrown outwards, the attraction force is so high, so it's again pulled inwards. Now when it moves inside due to its momentum, the repulsive forces are high, so it's again thrown out. And again it's again moved in, again thrown out. So it's kind of remains at this particular location. That's the equilibrium position. It doesn't change its position. It simply keeps on vibrating about that particular position. And this is how different molecules exist in nature. So now that you know how atom as a whole behaves or interacts with its neighbors, now why is this aspect important for our study? See, this is important because it gives us a brief outlook of how the exterior or the interior of an atom behaves, or what is its nature. So that's why this was a starting point of studying atom. That is, we now will venture inside the atom. Now that we know actually how it behaves externally, now we want to see, can we poke around inside an atom? So let's watch it. Now we came to know what was the nature of the scientific society in the early 20th century, and what were the ideas and what were the countermeasures taken by the contemporaries of the different scientists over there. So we also stated about the exciting phenomena which we discovered down those 50 years, and thereby stating out that the experiment and theory are very closely related and they walk hand in hand. Now we shall move on by picking up the biggest event of the 20th century in the field of physics, photoelectric effect. So let's see what we have for photoelectric effect.